This is the last question that we solved in the previous session, where we look at a case where the body starts from rest. So if it starts from rest, we have to start the graph from the origin. So in this section, we are going to look at other examples where the body does not actually start from rest. So this is the first example. A car is traveling at 10 meters per second when it starts to accelerate uniformly to a velocity of 25 meters per second over a period of 5 seconds. The car then maintains this velocity for 6 seconds before decelerating uniformly to 15 meters per second in 4 seconds. Let's draw the graph. So we will have our vertical line, and then our horizontal line, and this, give it like this, and then so this is our t, and this place is going to be our velocity v graph, the v axis. Okay, so let's start the question. So a car is traveling at 10 meters per second. So at the beginning, it's not going to be 0 anymore. So the origin here is 0. But let's say somewhere 10 over here. Let's say 10 meters per second is over here. So the body is actually here from the start. That is it. A car is traveling at 10 meters per second. No rest. Yeah. So if it is not starting at rest, we're not starting from the origin, we are going to start from this thing. So at this 10 meters per second, right? When it starts to accelerate uniformly. So whenever there's acceleration, you say there's a positive slope. So when there's positive slope, uniform velocity of 25 meters per second. So we are moving to a velocity of, let's say, 25 meters per second is somewhere here, right? We are accelerating to that over a period of 5 seconds. So yeah, let's say 1, 2, 3, 4, 5. So at 5, right? When we reach 5, we should reach this velocity after 5 seconds. So we are limiting here. So our acceleration should be something like this. Okay, so that's the first part. The car then maintains this velocity for 6 seconds. 6 seconds. So when we are here now, we have to add 6 seconds to this. If we add 6 to this, we are going to have 11. So we are moving to, let's assume in between them there are stuff, right? But because of space, I'm going to say that we are assuming we are somewhere here until we get to 11 seconds. Go to 11 seconds. But you have to label in from 6 up to 11. But then this is going to maintain. Say maintain this velocity for 5 seconds. So see what happens. What I do is going to be vertical, yeah, horizontal, right? So at 11, it's going to be, we are going to stop there. And this period from here to here is going to be 6 seconds. And this one that we did so far was 5 seconds, right? Yes, so we maintain this one for 5 seconds. And after the 6 seconds, what happens? Before decelerating, decelerating means we are going back. Decelerating uniformly. Take note of the uniformly. Uniformly means that this deceleration occurring in a straight line. So uniformly tells you that occurring without change. So uniformly straight line. To 15, we are decelerating, meaning whenever you are decelerating, meaning we are coming down. So we are initially at 25, but we are coming down to 15 meters per second. So 15, let me put this 15 going to be in between 25 and 10. So let me put 15 somewhere here. So from this 25, we are decelerating to 15 meters in 4 seconds. So for the time, this deceleration is going to happen in 4 seconds. So if we add that 4 to the 11, we are going to have 15. So let's say 12, 13, 14, and 15 somewhere here. Right? So the 15 is where we are coming to. So let me place that. So it's to get here. So this is going to decelerate here, and this deceleration is going to happen within how many seconds? Has happened within 4 seconds, right? So 4 seconds, that's what happened, and then we are now at this final velocity of 50 meters per second. This deceleration, they didn't say it decelerated to rest, or did it came to a stop. If they say it came to a stop, then we'll draw it until it meets the t axis. But then because it's not to a stop by a particular different velocity, we are specifying it and labeling it. This is the graph of this particular motion. Another example, the truck is moving at a constant velocity of 25 meters per second for 10 seconds. I like this question. So we have this going to this. Yes, so this is t again. and this is our um, velocity. So a track is moving at a constant velocity of 25 meters per second. So we are starting at 25. Let me put 25 somewhere here. Remember, this is in meters per second. So 25 somewhere here. We are keeping that 25 meters for 10 seconds. So here is 0, 1, 2, up to, let's say we reach 10 somewhere here. Right? Let's say 10 is somewhere here. 10 seconds. So 1, 2, 3, 4, up to 10. Then we are maintaining that particular velocity for 10 seconds. We maintain it horizontal. There's no acceleration, there's no deceleration. So we are maintaining it until we reach this 10 seconds. So from 25, we are not starting from the origin because we are not coming from rest or something like that. But it's starting from 25. We maintain that 25 for 10 seconds. So this particular period happens for 10 seconds, which is represented at the bottom here. Any other time that we will have will be added to this one so that you can label the graph accordingly. Okay, 10 seconds. It then decelerates uniformly. So straight line coming down. But then to where? To a 10, to a velocity of 10 meters per second. So let me say 10 is somewhere here. 10 meters per second somewhere here. We are decelerating, then it's over 5 seconds. About 5 seconds. So the extra 5 seconds will be added to this. So this one, let's say we assume 11, 12, up to 15. Let's say 15 is somewhere here. Right, so I'm going to label this. Yeah, so we are here. We should be here to have dropped the deceleration. It is coming down because it is decelerating. That's what it is, decelerating to 10 meters per second over 5 seconds. So this particular period is happening in 5 seconds. That's 10, 50 minus 10, we are having 5. So we are here. Now what this is, the track continues at this lower velocity for another 6 seconds. So we continue at this lower, which is 10. We now continue for 6 seconds. So 6 seconds here is going to be 6 plus 15 is going to be 21. So here is 16, 17, 18, 19, until we get to 21 seconds. So I'm just putting dash between because of space. If not, you are supposed to label it all in full, right? We are keeping this velocity continuing like this for another 6 seconds. So 6 seconds somewhere here. So we maintain this lower velocity until we reach here this point. Right? So this is happening within 6 seconds. This is happening within 6 seconds, and this is where we are currently. This is the graph of the motion. Let's try another last example. So you can quickly pause and then do this one on your own. But then let me quickly so this is not straight. This is not straight. So I have straight something straight like this. So something straight here. So I'm having T and I'm having V here. I took this traveling at a constant velocity of 30 meters per second. Let me put 30 somewhere here for 15 seconds. So 15. So we are maintaining this thing from 0 to 15 seconds. Let me put 15 seconds. So this is 0, 1 until we get to somewhere 15 seconds. 15 seconds. So let's say 15 is here. It then decelerates. So there's another deceleration, uniform deceleration to a velocity of 10 meters per second. So we are getting down to 10. We are getting down to 10 meters per second in 6 seconds. So the deceleration happened in 6 seconds. Here add 6 to the 11, 15. We are going to have 21. 21. So 21 is somewhere here. I'm just so they are going to move there. So we draw from here to here. So this particular thing is happening in 6 seconds. And after that, it accelerates uniformly. After decelerating, then you say after that, it accelerates uniformly to 20 meters per second. There's another acceleration. Whenever there's acceleration, we go up, we slope up. If we have a slope up to here, let's say this is 20 over the next 4 seconds. So 4 to this is going to be 4 plus 20, we're going to 25. So you go 22 up to you get to 25 seconds. So but then this is an acceleration. So the slope needs to go up. So this guy is going to be meeting somewhere here, right? So this 20 and the 25 are going to meet here, and then you accelerate. So you connect this point to this point, right? So we are done with this. So we finally got something as simple as this one, right? Yeah. So this is the what do you call it? This is a graph of this particular motion, and we are done with drawing the graph. So just take note when you have to start with from rest and when you have to start from particular velocity, then you follow the same process. If it is maintaining, continuing, it's a horizontal line. But if it's whenever there's acceleration, you go up. Whenever there's deceleration, you go down. Or whenever they say the body comes to rest, comes to stop, then meaning you have to decelerate down until you meet the t-axis. But in these cases, we are not meeting, we are not coming to a stop, but then we are coming to a lower velocity or going up a velocity, a particular velocity, that's acceleration. You read that. In the next session, let's try to do some simple calculation on these graphs of motion. Now that we know how to plot the graph, let's know how to also solve questions on them.